Okay, guys, welcome back to a new year. This is Miss Yanarella. In an effort to keep you guys on track while I'm out for some family business, I'm going to go ahead and teach the next two lessons, topics 3.1 and 3.2, in separate videos on separate days so that you guys can stay up with everything. So topic 3.1 is periodic phenomenon, and the definition of a periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equal length intervals. So the period of a function is the length of the x values that it takes for that function to complete one cycle. So you can see down here, this function starts here at the x value of -1. It goes up, over, down, and then it repeats up, over, down. So if they want us to draw two additional periods, what we're going to do is start here and count 4 units over. 1, 2, 3, 4. Again, 1, 2, 3, 4. Again, 1, 2, 3, 4. And again, 1, 2, 3, 4. And then for the top ones, we're going to count 4 as well. So we're going to go 4 here and then slide over 1. So starting here, 1, 2, 3, 4, slide over 1. Go back to this point. 1, 2, 3, 4, slide over 1. Go back to this point. 1, 2, 3, 4, slide over 1. And now we're just going to connect those dots. So here, 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 and here. And there you have it. And so what they usually do is they say, okay, from this point to this point equals the period. All right, a portion of the graph of the periodic function g is above. What is the least possible value? In other words, you can say it repeats from here all the way to here, but there's a second repeat in there. So what we're going to do is find the least possible value. So what you can see is, let's just count from the low points. So from this low point to 1, 2, 3, 4, 5, this low point, we have a period of 5. Okay. So the least possible value is 5. So now we're going to use this function to determine the following values of g, even though they go off grid. So for instance, g of 14, well, we can say that's the same as g of 4 plus 2 times 5. Because what we're saying is there are two periods to get to g of 14. So we can always say, if you go two more periods, you really haven't, you've reached the same spot. So we're really looking at g of 4, which is on this grid, and g of 4 is 7. Okay, so g of 72, you can see where we're going with this. We're dividing out periods of 5 from 72 and using whatever's left over. So obviously 5 goes into 70, but then you'll have 2 remaining. So that's going to be 2 plus 14 periods of 5. And then these will just cancel out because the 14 periods of 5 will bring us right back to what the value 2 was. And so g of 2 is 6. And now g of -17, we're going in the opposite direction, but you can still subtract out periods. So that's going to be g of 3 minus 4 times 5, because 4 times 5 is -20. And then if you add 3 to -20, you come back to 17. And again, we're going to scratch out 4 periods of 5. Because you'll just go right back to the same spot. So that's going to be g of 3. And as you can see, g of 3 is 7. All right, moving along. In example 4, the graph is indicated with a period of 5. We need to know that it's a period of 5. So 1 would be the same as 6, would be the same as 11, would be the same as 16. Okay, so when I want h of -2, what I'm going to say is that's similar to saying h of -2 plus 1 times 5, because -2 plus 5 gives me, nope, sorry, got to go back. My bad. This is we're going to say 3 minus 1 times 5, because 3 minus 5 will give me -2, but you can scratch out the periods because the periods that repeat will take us right back to h of 3, and you can see that h of 3 in our chart is 0. So now h of 6 would be like saying h of 1 plus 1 times 5, 1 period of 5. And we're going to scratch out the period and say that brings us back to h of 1. And that should give us -2. h of 9. Well, we're going to start with the first h of 9 and say that's like saying h of 4 plus 1 times 5, 1 period of 5. And of course, that means we'll go right back to h of 4. And h of 4, as you can see in the chart, is 3. So now I need h of 3 because we've got double h functions. We've got composites. And h of 3 is simply 0. When they say h of 5k minus 3, where k is an integer, we're basically saying h of -3 plus 5k. And that's exactly what we're doing, is taking out all periods of integer units 5. So that takes us to h of -3. And now we're going to have to convert h of -3 to saying h of 7 minus 2 periods of 5. 2 periods of 5 will give us 10, and that's a -10. So 7 minus 10 is h of -3, but we're going to scratch out the 2 periods of 5 and say we see in our chart that h of 7 is 2. Okay, moving on. Okay, so it's useful to have notation to model this phenomenon. A periodic function starts with a basic pattern and translates that pattern repeatedly over its domain. So what you're doing is a horizontal translation. You can see in this, you've got this V shape that translates horizontally from here to here. That's 1, 2, 3, 4 units. So this is a period of 4. So remember in example 4, the period of H was 5. Well, in this one, the period of F is 4. So I'm going to write that. The period of F is 4. So we need 2 full rotations. So the way they wrote it is F of 2 equals 1. So any input value F of 2 plus 4k, where k is an integer, gives an output of 1. Since F of 2 is 1. Okay, so here is the example they're talking about in 6. So we have a clock mounted on a vertical wall, and the clock has an 8-inch long moving hand. So this is 8 inches. And then the distance down to the floor is 120 inches. And then what they're saying is at time t is 0, so we're going to put time on the x-axis in seconds. And we're going to put height on the y-axis in inches. So they're saying at t time is 0, the second hand is all the way up high. So we're going to put 0 right at the highest point of this graph. And then they're saying that it's twice as fast as a regular clock, so it repeats the cycle in 30 minutes. So you can see where the period is. It goes from F to P before it repeats. So this would be 30 minutes. I'm sorry, our time is in minutes, not seconds. Let me go back and fix that. So we know that J is immediately between 0 and 30. So we're going to put 15 on J, and these are quarter points. So a quarter of 30 is 7.5. And if you add 7.5 to 15, you get 22.5. It's well worth marking these axes before you start. So remember, if the center is at 120, I'm going to put my numbers over here so they don't get mixed up with my times. The center of the clock is this dashed line. And the highest point is 8 inches above, so this would be 128. And of course, the lowest point would be 20 inches below. So the tip of this clock is going to be 8 inches below 120, so that would be 112. All right, so now what they want us to do is tell the exact values of the points F, G, J, K, and P. So no rounding. So what we're going to do is say F is at an X value of 0 and a Y value of 128. G is at an X value of 7.5 and a Y value of 120. J is at an X value of 15 and a Y value of 112. K is at an X value of 22.5 and a Y value back to 120. And the last one, P, is at 30X and 128Y. Okay. So the next question says, referring to that graph, the T coordinate of G is T1 and J is T2. So we're going to label G as T1 and J as T2. And you can see this part of the graph from G to J is concave up, but it's decreasing. So we know that because the values go from 112 to 128, it's positive. It's not a negative function, so we'll scratch out the negatives. Now from T1 to T2, we can see that it is decreasing, not increasing. So B is correct. So these words that I'm about to write are very important. You're going to use these over and over. Describe how the rate of change of H is changing over the interval from T1 to T2. And you're going to say the graph of H is decreasing. Actually, no, I'm sorry. Let me say it this way. The rate of change is increasing. You know what? I'm going to type it because it's going to take me forever to do it this way. So we are going to say the rate of change of H is increasing because the graph of H is concave up on the interval T1, T2. And those 1s and 2s should be small. And there you have it.